All right, now we're going to move into toxicology and chemical risks. So we're going to be discussing like some of the definitions here. Something that's toxic is something that is known to be like poisonous. It damages or kills cells and tissues. And typically it's something harmful in small concentrations. You may have heard that the dose makes the poison. And this is true. Like you can drink too much water and be killed. Water is not toxic. However, in large concentrations, it could be. So something that is toxic, typically harmful in small concentrations. Something that is hazardous is dangerous but not toxic. So it might be flammable, might be explosive, it might be an acid or an irritant, but it's not traditionally toxic in those small concentrations. And now we're going to talk about some categories of toxin. First category, neurotoxin, a chemical that disrupts the nervous system of animals. So something that interrupts the nervous system would be a neurotoxin. Carcinogen, something that causes cancer. And this goes hand in hand with mutagens. Mutagens are types of carcinogens that cause damage to the genetic material of a cell. And as far as I know, all cancers are going to result from mutations that cause cell growth to happen without being stopped. So because of that, something that causes mutations in certain types of cells, so for example, UV radiation causing mutations in different genes in skin cells can cause cancer. A teratogen is any chemical that interferes with the normal development of embryos or fetuses. So a good example of a teratogen is thalidomide. Thalidomide is a sedative drug. It was discovered at the end of the 1950s, and it caused this worldwide tragedy because the drug was prescribed to pregnant women to relieve morning sickness or pregnancy nausea. When it was given to those women, you can see here we've got pictures of babies who have underdeveloped or undeveloped limbs. That was a common symptom of a thalidomide baby, is having arms or legs that did not develop properly. And this happened because there wasn't a lot of testing on thalidomide, and so they didn't know that it was going to be a problem for fetuses because it was not a problem for the pregnant women. And this is one reason why today, we don't have a lot of meds that are approved for use in pregnancy. They actually class them. So something that is class A has been shown to be safe in pregnancy. And then you might have things that are class B or class C that are well, we don't think it's a problem, but there's no research on it because no one is going to do a study giving pregnant women something that might harm their babies. That's just not going to happen. It's not going to get past approval. So some women may take drugs that are class B or class C if they have some other condition that is possibly damaging to them, but it's not going to be a full-scale study. All right, allergens. Allergens are chemicals that cause allergic reactions. They can act indirectly. So formaldehyde can act indirectly, like in sick building syndrome. It can cause allergic reactions, or it can be something that causes an allergic reaction very directly. So basically, as soon as you are in contact with it, and you can get this allergic reaction that is immediate and aggressive, closing up airways and things like that. An endocrine disruptor is a chemical that interferes with the normal functioning of hormones, so of the endocrine system. Things like people taking steroids, those would be endocrine disruptors because they're interfering with normal hormonal function. Typically, endocrine disruptors can cause some wild symptoms because they're interfering with hormones, and so they can cause feminization in males and masculinization in females because it's interrupting that normal hormone, causing those secondary sexual characteristics. Immune system depressants, these are things that depress the immune system, and so those can be a chemical problem. Now, in addition to more, those chemicals and toxins, we also need to talk about other things that can impact health. So diet. There is a correlation between high-fat, high-salt diets and cardiovascular disease. 60% of U.S. adults are overweight. This is because of diet, and that can lead to lots of issues like cardiovascular problems, diabetes, high blood pressure, all sorts of things. All right, so we're going to kind of shift back to talking about some of these chemical compounds because some of these things are things that are naturally found in the diet, so things that you might consume, and some of them are like chemical things that are maybe found in your diet or getting into you from contamination. But anyways, if you have a substance, toxic substance, or it could just be a substance that is harmful but not toxic in the same ways, if it is water soluble, so something that is acidic would be a good example of something that's water soluble. It can be washed off of surfaces. It can percolate into the groundwater. It can get into runoff into surface waters like rivers and lakes. And it can move through the environment rapidly and into cells easily because it is water soluble, so it's going to mix with the water. Things that are fat soluble are not soluble in water. This is like when you have, oil and vinegar. Vinegar, water soluble. Oil, not. So it's a fat. They're found in higher concentration bound to the soils, including the benthic soils that underlie bodies of water, because they don't mix well with the water. They need a carrier to move through the environment, and they can penetrate tissues easily once in the body, and then once they're in the body, they can be stored in fat cells long term, and so they can persist in the body for longer periods of time. The other problem with things that are fat soluble is because they are stored in the body, you might get them stored up in an animal that might be like, for instance, going into hibernation that has a ton of fat. And then over the course of hibernation, all of that fat soluble compound can be released into the body at once, which can cause health issues. All right, so we're going to talk about bioaccumulation and biomagnification because that relates to this fat solubility. And that's probably will stop shortly after that. We will do this measuring toxicity portion in a separate video. So you can be exposed to toxins by food, air, water, or by like physical contact. In the case of bioaccumulation and biomagnification, we went over this at the very beginning of the year, but this is a good reminder because it could show up on that exam. An increased concentration of a chemical within an organism over time is accumulation. So I eat a bunch of a toxin and it builds up in my body. That is bioaccumulation. Biomagnification is it going up the food chain. So this is where we saw like DDT and it got into the water, and so photosynthetic algae picked it up, and then dinoflagellates or zooplankton, and then it got into small fish, and then it got into large fish, and then it got into the birds who ate the fish. And in the birds, there was so much DDT because it had magnified as it went up the food chain, meaning that the DDT did not get processed out of the bodies of any of the organisms. So it didn't get like urinated out. And so that DDT, once it got into the birds, it was in such high concentrations that it could affect things like the thickness of their shell. Persistence is how long a chemical remains in the environment. So DDT is also persistent, which is a separate but equally bad problem. Persistence means that the chemical can just hang out for sometimes months or years. PFOA, PFOS, phthalates, and DDT are all good examples of persistent chemicals. This is why a lot of things nowadays do not contain phthalates anymore. You'll see that on a lot of shampoos and body washes and all sorts of stuff because it is persistent. And we want to try to avoid persistent chemicals as much as possible. It's better to use a chemical that will break down more quickly in the environment because then it's got less chance of being toxic over time. All right, so elimination. I said in biomagnification that the toxin doesn't get passed out of the animal like into the urine. So that would be excretion. You can excrete things by exhaling, you can put them in urine, you can put them in feces. Or you can have metabolic degradation, which is where the animal would metabolize the toxin into another form. And this is going to happen in the liver. As we are getting into this COVID-19 self-isolation quarantine stuff, you may hear on social media lots of things about how to detoxify yourself. You do not need to. You have a functioning liver. Well, assuming you have a functioning liver, you're good. It's doing the detoxification. Don't overburden it and drink a whole bunch of toxins or eat something that's toxic. But for the normal things that you are eating and drinking, if there's any like small traces of toxins in them, your liver is doing a fine job taking care of that. All right, we are going to pick back up with the measuring of toxicity in the next video.